If you take a moment to look around, chances are you'll spot something that was welded. Whether it's a railing, a vehicle frame, or even the chair you're sitting in, welding is everywhere. Maybe you've already cut, welded, and fabricated metal before. Or maybe you're just starting out, curious about the possibilities this craft has to offer. Wherever you're coming from, this module is designed to give you a solid foundation. We'll walk through the core processes and terminology that define welding and cutting so you can work safely, efficiently, and confidently. Let's start with the most important part, safety. Before you install, use, or service your equipment, make sure you've completed the safety module and reviewed your owner's manual. Welding and cutting involve intense heat, light, and fumes. So proper PPE, or personal protective equipment, ventilation, and awareness are essential for your safety. Safety isn't just a box to check. It's a mindset that protects you and others around you. Now let's talk about the processes themselves. The American Welding Society recognizes over 90 different welding and joining process methods. Some are basic, and some are highly advanced. In this module, we're focused on the most common heat-based processes, the ones that melt and fuse metal using a flame or an electric arc. We'll begin with one of the oldest, Oxy-fuel. This process uses a fuel gas like acetylene mixed with oxygen to generate heat from a flame. It's portable, doesn't require electricity, and can even weld aluminum if you know what you're doing. But it's relatively slow and demands a lot of operator skill, so it's not commonly used today. While oxy-fuel cutting is effective for steel alloys, it's limited in scope, and most welding applications today have shifted to arc-based methods that give greater speed and versatility. Next up, shielded metal arc welding, or SMAW, better known as stick welding. This method uses a flux-coated electrode to generate an arc with the workpiece. It's simple, affordable, and works well outdoors. Stick can produce high-quality welds, but it's best suited for metals thicker than 1/8 of an inch. You'll need to chip away slag after welding, and spatter can be a challenge. Electrode efficiency is around 60%, meaning a good portion of what you buy doesn't end up in the weld. To improve on that, we have flux core arc welding, or FCAW. This wire feed process uses a tubular electrode that's filled with flux. It can be self-shielded or it can be gas-shielded. Flux core arc welding boasts productivity and eliminates stub loss, allowing for longer welds and a higher electrode efficiency. In fact, the efficiency improves from 70 to 80%, making it a solid upgrade over stick in many applications. And then there's gas metal arc welding, or GMAW, more commonly referred to as MIG welding, which stands for metal inert gas, or MAG welding, metal active gas. This is a wire feed process that uses a continuously fed filler metal electrode and shielding gas to protect the arc. It's highly efficient, up to 99% with advanced waveform control, and capable of welding nearly all types of metals and thicknesses. MIG is flexible, fast, and ideal for long welds. While basic MIG can produce spatter, adjusting your settings can virtually eliminate it. And when done properly, MIG welding can be easily automated and is common for manufacturing. And for precision work, we turn to gas tungsten arc welding, or GTAW, most commonly referred to as TIG. You might also hear this referred to as heli-arc welding. TIG uses a non-consumable tungsten electrode and an inert shielding gas, typically argon. The operator adds filler metal to the puddle, allowing for exceptional control. TIG is the cleanest process. It produces no sparks, no spatter, and no slag. It's perfect for your high purity applications like stainless steel kitchen equipment, aerospace components, and process piping. It's slower and deposits less metal than MIG, but it can weld nearly every metal that's considered to be weldable. Now, let's shift to cutting. Carbon arc cutting uses a carbon electrode, similar to stick welding, to melt steel, and compressed air blows the molten metal away, making it great for repairs, commonly called carbon arc gouging. Plasma cutting is more refined. It uses a slightly consumable electrode similar to TIG to generate a narrow arc, followed by compressed air to remove metal. Plasma offers greater control and precision than carbon arc, and much more capability than Oxy-fuel because it can cut any metal that conducts electricity. So, aluminum, stainless, copper, and any materials that can't be cut using Oxy-fuel are typically cut using plasma. And finally, we're seeing a rise in laser-based technologies. Once reserved for automated industrial applications, handheld lasers are now entering the market. They're being used for cutting, surface cleaning, and even joining, whether it's welding, soldering, or brazing. So what should you take away from all this? This module gives you a head start. Welding is more than joining metal. It's about understanding the tools, the science, and the skill it takes to produce a high-quality joint. Sound interesting? Come on, let's dive deeper.